Yeah, I don't know what this could be saying. Something, this looks like brilliant mind, maybe? Oh, well done, brilliant mind, maybe? Okay. All right, but let's finish up part 3 here. What if the swap command could swap entire nodes, including the branches that grow from the nodes? Such a structure would perfectly reflect the hierarchy, for example, that of noble houses. When a house changes sides in a conflict, it often takes its lesser vassals with it. Yes, it makes perfect sense. The final version of the swap command shall work exactly like that. Here's the final list of commands. Build 2 binary trees, taking into account the new behavior of the swap command, and read the message just as before. I nearly forgot a special case to make the structure even more perfect. What if multiple levels of the tree contain exactly the same number of nodes? Well, in that case, choose the one that's closest to the root. Okay. That's not something I don't know if max by, right? We have the code that does max by to search for, where did I put it? Here. I don't know if this will always find the lowest level. I guess we can look at the docs and see if it, oops, if it says anything about that. Turns the element that gives a maximum value with respect to specified comparison function. If several elements are equally maximum, the last element is returned. Okay, so it's doing exactly the opposite of what they're requesting here. Great. All right, we can fix that. So here's an example, and we're actually swapping the entire tree now. This might be a little tougher. Okay, let's do download. Let's take a look at oh, okay. It is longer. It's 200 nodes instead of 100. That's fine. It's the swapping of the full tree. So which means we're going to have to actually pass that in here, whether or not it's tree. So let's create a little thing here. Enum swap operation. Swap op. So swap op is going to either be single node or full subtree. Let's just say subtree, right? And now this is going to be, we're going to pass in the swap op. Right, and we're going to say match swap op. And if I do this and single node, we already have the code to do the single node. All right, so here the swap op doesn't matter. Swap op single node. And this swap op single node as well. Oops, 2 colons is the way to go. All right, so we should still bake and run. Yep, and we're not using a subtree, and I think this is still the right answer. Let's find out. RFZ starts with and ends in JBWS. Yes, it does. Okay. So now our final one is going to be, I guess we can do this. Oops, I didn't mean to delete it. That's fine. And this is from part 2 to part 3. This is going to be test part 3 one. We're going to comment this out and run this and change that to 3 and parse and build. Swap op subtree. There. Unable to open the file. So let's cat into 3.1. Oops. Oh, shoot. I didn't mean to do that. Let's grab 2-1 again. Put it back. And now 3-1. There we go. And now let's go down to 3. Where's part 3? This is part 3. All right. So now if I hit run, yeah, we get not yet implemented. We haven't implemented this. This is a little trickier, isn't it? Because we need to move the entire thing over, which means, yeah, if we're just moving a single node, that's fine. But if we're swapping D and I, for example, we need to get D plus all of its, anything it's pointing to, plus anything it's pointing to, all the way down to the end. And then insert that here. And we can't just use a regular insertion function. We actually have to just force everything into the same place as it was before, which is going to be tricky because they're going to be at different levels. Or they, in this case, they're at the same level. So all of these indices will be the same. But, for example, these are different levels. Oh, you can in fact just swap the whole tree. I wonder if we should make an optimization for that. If swap is 1, we know it's going to be that first node, and therefore we can just do a simpler swap. But there's only 200 nodes, and how many swap commands are there? $401. So we could just do it without having to worry about it. Okay, so how do we do it though? We can find the node in the position using the find by ID. But now what we need to do is extract. Maybe we write a little extraction function which generates a new tree from an existing tree. We'll say fn extract mute self starting at position pos, and we're going to return a vec tree. So we're going to say let mud result is vec tree default. But we have to maintain. I'm trying to think if we can do this recursively, just like we did with the levels, right? And we can have, let's say self, we can't do a traverse because traverse is just for that, but it's going to be the same code. What do we want to call it? I've already used the term extract. We're going to pass in the position of the node. Actually, here we don't need to return the node, right? We can, it's okay, it's okay. I was thinking, well, I can just reuse that code. I can, it's just going to be cloning the node unnecessarily. But we'll live with it. We'll live with it. What I'm stuck on right now is the name. I'm just going to throw an ASDF in there. So we're going to pass in the source position, the destination position, and the result. Result. And then return result. It's basically just like we did with levels. And now I'm going to say this new function, which I call ASDF. Source, usize, dest, usize, and then result, which is going to be a mute vec tree. And it doesn't return anything. And so now we're going to go left, mid, and right. So we can say if self has source times 2 plus 1, then we're going to say self ASDF, and I'm going to call it something else. ASDF of What am I passing in here? This definitely is source times 2 plus 1. But we need to specify the destination of this guy is probably also dest times 2 plus 1. And then result. And now we handle the current node, which goes into dest. So we're going to say let node is equal to self vec take source. Can I do that? Oh, vec get source take. That's what I meant. That's an option node. I guess what we can do is here is as ref unwrap take. I don't know if that'll work. And then we can say result vec of dest is equal to node. And then we'll do the same thing for the right side. Right? And this should be able to extract it. Yeah, so we can't. I need to be able to pull it out of the vec, but not by removing it, replacing it with, okay, do we have a replace? Can I do this? Source take. Yeah, okay. So this should extract a tree from another tree. And then after we've extracted it, we want to insert it. And is it the same kind of code? I think it is. At the new position. And maybe we call this function plant. Fn plant itself. Other vec tree. And now we need another function that we can call because we want to set this up recursively. Self QWER. Starting at, we have to tell it where we're going to put it. Position usize. Position 0 other. Right? And then fn QWER, mu itself, position usize. Oh no, source dest. Dest. Source. Other vec tree. Okay. And it's basically this. Let's copy and paste this, except we're going to rename the functions, obviously. QWER, and it's dest and source. All right, if there is something in the source tree, in the other tree that we need, so then this becomes other vec, and then self vec dest equals node. I have no idea if that any of that's going to work. And then there is no result parameter. There's an other parameter. All right. I mean, it compiles. Oh, this should be. Oh, I can't take it. But I can clone it. Yeah, which means I don't need to do it in 2 steps. Right? So let's call this extract tree and then plant tree. Subtree. Right? And then call this plant subtree. There. That's a little bit better. Better naming. So then this here becomes we want to get the ID. guess we could do that regardless, right? And we still want to grab these guys here, right? So then the swap op simply becomes, we want to extract let left equals extract, left tree extract starting at position left pause, and let right is equal to right tree extract at right pause, and then we're going to say plant tree left plant tree we're going to the right tree at the left pause, like that, and right plant right pause the left tree. Keep doing that when I redo the renames. Okay. These need to be mutable. Oh, should be left tree plant. Okay. But it still doesn't work. We get a panic of out of bounds at 195. Okay, so we need to fix that. Those don't need to be mutable. Oh, this should just be right and left. There, okay. The len is 0, but the index is 3. What's 195? Right here. It could be that this is just null, but I do need to extend the tree, don't I? So I can say if result dest is greater than or equal to result len, result resize with dest plus 1, default. So I do need to extend it that way. I probably need to do the same thing here. Veclen. Vec resize with. 5 not found. That's not a good sign. We are currently looking at test 3.1. And we saw swap 5. Here's ID 5. So it should have been added to the tree. Oh, I guess after the swap, yeah, there must be a bug on the swap code, obviously, right? Let's say before swap, left before equals left tree, and right before left extract, and then right extract, and then left after, and right after. After, not fatter or fader. Okay. Does this help? Who knows? The left before looks like A, B, D, C, F. Let's see how that compares here. A, B, D, C, F, yes. And then right before looks like H, O. Oh, I probably printed it. Yeah, I have a left tree here. I'm going to say, that's weird. Why would the trees be the same? They're not. Okay, so we have H, I, J, L, M. H, I, J, L, M. Perfect. Then we extracted the whole tree. A, B, D, C, F. Extracted this. So that left after only has H and a bunch of nuns. So it looks like we'd stopped after the first one. Okay, so let's figure out why. Oh, not self-vec has. We care about the self-vec. It's other. Yeah, if the other has an entry, then we need to do it. Now we're panicking here because we need to do the extension. Oops. So much code duplication. Self. There we go. FKMGL. Is that right? Nope. It's DJC. Oh, we got the GL part right. Oh, yeah. FKMGL. Oh, yes. We did it right. I just have to fix the max by because these are equal, right? DJ and FK, and the max by will only return the last one that's equal, not the first one that's equal. Okay, so let's fix that. At least that's only in one spot. So I can just say this, let mut result equals, it should be none. I should be doing none here and then doing an unwrap on it, right? So and then I say for level in self levels, if result is none or result unwrap len is greater than level len, then result is some level, and then return result unwrap. And that way it'll fail if levels. Oh, option string. I forgot the colon. Clone. Take away a semicolon. Use a move value here is after the move. Unwrap clone. Nope. It's an option string. So I'll unwrap. Oh, Jesus Christ. As ref. There. So can I get rid of the clone now? I can. And can I get rid of all the print statements now? HA. That's wrong. So I basically messed up my max by here. What? Did I break something here? It's stopping after the first one? Why do I feel like an idiot right now? Levels is a vec of string. Level is a string. Oh. Okay. I think we got it. I was pretty much being an idiot. Okay, DJ MGL. And I think that's right, DJ MGL. Let's do this one also. Test 3.2. because I'm nervous about this one. I don't know if I got it all the best here. So let's change that to 2 and see if we get the same answer. Yeah, so this is saying one additional swap command at the end can change the answer. Interesting, both nodes of identifier 5 are located in the same tree. And so it's also possible that one ID with the node 5 is a subtree of the other ID with node 5. Oof, exciting. So if they're in the same tree, we should be able to just swap them around within the tree. I can totally do that. And we can see if that gives us what we're looking for. What I should be doing then is having find by ID return an option of a found struct. All right, let's do this. Struct found. And it's going to have a node and a position. And then find by ID is going to return an option found. And we're going to say found node clone, and position. Sum. Otherwise, return none. We don't find it. So now we're going to change this to be found left, and found right. Right, and then down here, I guess this, for the single node case, we're always, because that's a single node case, always will work because we know it works. We're going to say found left dot pause. Oh, I have to unwrap it. Can I do this then? Left pause left node is equal to found left unwrap. Oh, I can do found like this. Oh no, they have to have the same name. I thought I could extract that way. Okay, left, right. So this is left dot pause and right dot pause and left dot node and right dot node. Okay, so that should still work. But this now is going to be different. If we found on the left, but not on the right, we could find multiple on the left and multiple on the right. Okay, so that means that we want to make this actually entry of vec of node and pause. usize. Wow. Okay, this is getting annoying. And then impl found fn pause self. We're just going to return usize, and it's going to just be the first one, entry of 0 dot 1, and then fn node self of node entry of 0 dot 0 dot clone. Right, and then we come up here, and instead of unwrap, so find by ID is going to return this node option found, and then this is going to be found, so we can say found left dot pause. Right, because this is a found type now, and then a node and node. But now we need to check to see if we have 2 on the left or 2 on the right. We're going to do the swap a little differently. But if there's 1 on the left and 1 on the right, then we're good. So how do we want to handle that? If left is empty, it also means we have to change find by ID. We can't just return. We need to return a found vec of found. Let result equals vec new. And then we'll just say result dot push, and then say result here. Oh, found is already a vec. Yeah, so we should just say found here. And then say push. No, it's result is found. Right? Default. And then result entry push. Did I do it the other way around? Pause node clone. I'm going crazy right now. What did I call it? Node. Okay, so node and position. I do have it backwards. There's no default for found. Yeah, I know. I just want to make, I want to get this to compile. I have a dot where I should have a comma. One of the expressions, like that. Okay, so that looks like it's clean. So found left, if found left is empty, that means we have to have two entries on the right that we need to swap internally. And I can try to do it just the way we have it here, but I'm worried about that subtree case, the case where the subtree of a swap, I don't think that would work, all right? And what I mean is, what if we're swapping this and this? It's 25i with 28m. How would that even work? Because what happens with L? Because if we take I out of the equation, then M is gone as well. Right? What if we're swapping D and K? Well, D is these three and this. We can't put that up there because K has N as its sub thing. So it would, yeah, I don't know how that would work. So let's assume that doesn't happen. And then if it does, I'll have to deal with that at that point. So found left is empty, then we have two rights. Let R1 is equal to right tree extract. I'm going to say left entry of 0 dot, found left. Yeah, we don't need to unwrap these anymore. So these should just be found underscore everywhere here. Okay. So this is found left, entry 0. It should be a little thing because I'm going to get it backwards every time. Node and then use size. So 1 is the position. And then R2 is going to be right tree found entry 1 position. Oh, sorry, this should be right. Okay. And then we're going to say right tree plant. I guess what we could do is say let P1 is equal to found right entry 0. And P2 is this guy. And that way I can say P1 and P2 and then plant in position 1, extracted tree 2, and then write tree plant P2 R1. Yeah? Else if found right is empty, then we can do exactly this, except all backwards. Oops. Like that? Okay. And all of the rights here change to left. And I guess this changes to L1 and L2. Okay, otherwise we use the same swapping strategy we had before. Oops. Where this is found left dot pause. Okay. Why can't we find that? Okay, and this doesn't like, oh, self dot entry. Okay, oops. Found left entry. DJCGL. I mean, it worked for the test code, right? We were able to do the swap 5 in the same tree, DJCGL. The question is it going to work for my real input? It did come up with a, oh. Did because it's not using the new code. Subtree. Let's try again. Wow, it's slow. I wonder if I have an infinite loop somewhere. Let's see, ps-ef grep request, make sure it's not running, cargo run, release. Yeah, I must have an infinite loop somewhere. Oops. Let's see which swap op we're working with here. Println line. Okay. Oh, no, it did. It finished. It's just very slow. Okay, let's see if it's right. Quack, yeah, you're crushing it. That's the right answer. Okay, global place 46, global score 105. And it took me an hour and a half to do all of that. Let's see what my progress is.